Okay, here is a geometry problem, and we have a triangle ABC in color blue, and we construct two squares from the sides AB and AC. And for AH is perpendicular to BC, we extend the AH and meet the line segment EF at point M. We want to prove that M is a midpoint. All right. So I'm going to present maybe a few methods, and why don't you think about it if you can solve the problem, or even better, you solve it in more than one method. All right. So pause the video, think about it, and then when you're ready, let's continue. So in the first method, we're going to construct two vertical lines from midpoint M. Of course, midpoint is to be proven, right? So from M, we're going to have, let's say, X. Okay, let me mark it. Let me see here. Let's call this X. This is Y here, perpendicular. This 90 degree here. So I claim that there are two pairs of similar triangle. Can you spot them? All right. So notice that this is 90 degree here, right? Because they're squares, and the size. Let's mark it, right? This is a C, this is a B. Everything here is a square. This is C. This would be C. This would be C. This would be C. All right, that's good. Now let's see the green angle here. I mark it as 1. The other one I mark it as 3, and I mark this angle is 2. All right. So notice that 2 and 3 add up to 90 degrees. That's very clear because in the right triangle, 2 and 3 add up to 90 degrees. But how about 1 and 2? Because 1, 2, and this right angle here add up to 180 degrees. Of course, in that case, 1 and 2 plus 90 degrees equal 180 degrees. So if you cancel, that's equal to 90 degrees. So from these two equations, you know that 1 equal to 3. Now here, let's look at two triangles that are similar because they're right angles, and 1 equal to 3. So this angle here, let's mark it here, and that one, you know, the two are similar, right? So with that, the corresponding sides are proportional. So let's mark them, right? So I'm going to erase the marking here, right? I'm going to erase the marking here. So what the size I'm interested in is, let's call AH, let's call this size H, and then let's call AM, let's call this size M, and let's call this X, let's call this Y. Okay, so the length of the segments, right? So since two triangles are similar as we marked earlier, so it's corresponding sides here, I'm interested in H and C from triangle ABH, right? So ABH is similar to AXM. Yeah, so here I'm going to have the size C and H, the corresponding one, and the corresponding C would be M, right? M and X. All right, that's good. Now, similarly, on the right-hand side, I claim that if you look at this triangle and the other triangle, use a similar argument. They are similar, and then use a similar argument. You know that the corresponding size, in this case, H and B, yeah, B and H, must proportional to, here would be B and M, right? So, sorry, not B and M. This would be Y, yeah, Y and M, yeah? So, would be M and Y, yeah? So, it's corresponding. Now, from these two, you know that CX equal to, from the first equation, CX equal MH, but from the second equation, MH equal B times Y. But, okay, let's erase some marking here. Let's look at what the meaning of this, right? So you notice that this is B, yeah? Let's mark it. I'm gonna mark it with this one. So you notice that B, yeah, and Y, yeah, BY here would be the trace of the area of triangle AMF. Yeah, so BY here, this is, let me write it here. So BY here, this is 2 times the area of triangle AMF. Now similarly, when you look at C and X, right? Let's mark it again. This is C, yeah, and this is X. So it is a triangle AME, yeah. So equal trace of triangle AME. So, all right. So I'm gonna erase that marking again. So what we're saying here is that the triangle here, yeah, this triangle, and change the color here, and the other triangle, yeah, they have same areas. So in that case, I claim that M is the midpoint. In other words, ME equal MF. You may wonder why that is the case, right? So if I have a triangle here, yeah, let's say M here, I have such that this is E and F, right? So if I have two areas equal to each other, so what is the meaning of this, right? This area equal to this area, yeah? So the area is base times edge, right? So earlier we're looking at this side as a base, but here, what if I look at this as a base? Then the height is going to be this one. This is going to be the height. This is going to be edge. And the right-hand side, the height is also edge, right? So then the two base must equal to each other. In this case, two base would be one is this base, the other one is going to be that base. So this M is going to be the midpoint, right? So we prove it. This is a method number 1. All right. So let's go to method number 2. So in method number 2, what we're going to do is I'm going to construct a line parallel to AH from point E. Okay. So this is going to be parallel line. Yeah, parallel line. Yeah, to AH. Okay. But I'm going to let this line meet with the extension of AF. So I'm going to extend AF here. Yeah. And this line meets at, let's call it G. Right? Oh, sorry. G is used. So I'm going to call it, yeah. I'm going to call it T. All right. So here I claim that I have congruence triangle now. Now, can you spot it? Congruence triangle here. So remember, ET parallel with MH, right? And I claim that the triangle here, first of all, the sides, this is a C. Let's mark it, right? This is a C here. Okay, that's good news. So I have one sides equal to each other, right? And since I have this angle here, let's look at this angle here, right? Yeah. So this angle is actually 180 degrees. Then let's call this is the other angle. I claim that they complement each other, right? So if this is angle 1, this is angle 2. So I claim that 1 plus 2 equal 180 degrees. Why? It's because the other is 90 degree. This is 90 degree, and this is 90 degree, right? The full circle is 360 degrees, right? So 1 to 180 degrees. Okay? So here, but when let's erase this here, erase this 90 degrees. However, you notice that this angle here, yeah, complement of 1 is going to be this one, right? So this triangle here, this angle here, yeah, let's call it 3, right? This is angle 3 here, equal, right? So in other words, 1 and 3 add up to 180 degree. So 2 and 3 equal to each other. Okay, so I'm claim that the two triangles are congruent. Okay, I'm running out of color, but let's mark them. One is ABC, the other one is this triangle here. Yeah, so one side is equal, this angle equal, right? 3 and 2 equal. I just need to find another angle that are equal to each other, right? So let's do that. How do we find that? Okay, so here we're going to use an either way, yeah. Okay, so here, for example, this angle, right? Let's call it the 4, right? That's 4, but 4 because this 9 is parallel, right? ETN parallel, so must equal to I call this 5, right? This is equal to 5. 4 equal 5, right? So I said that 4 equal 5, yeah. And for the 5, when we think about it, is there is a 90 degree here, right? This is 90 degree here. So let's call this angle here, yeah. This angle, let's call it 6, yeah. So 5 plus 6, yeah. So 5 plus 6 equal 90 degree. And 6 plus 7 is 90 degree, yeah. 7 plus 6 is 90 degree. So what do you have? You have 5 must equal to 7, right? So 7 equal to 5 equal to 4. So this is two triangle. I have 4 equal to 7. I have earlier, I have this triangle, this bigger one, number 2, right? Equal number 3. Yeah, 4 equal to 5. And the sides equal here. This is C and this is C. So I say that triangle ABC is congruent, right? ABC, yeah, congruent with AET. Okay. Yeah. So when they are congruent, what you can know is that this one, yeah, must equal to the size here. Let's call it the B, right? This must equal to B. But then this is also a B, yeah, because so which means you have, let's look at the big triangle here. All right, let's look at this big triangle here. Oh, sorry, let's erase it. Okay, let's look at this big triangle here, right? This big triangle, yeah, I have this B equal to each other, right? Okay, so this is going to be midpoint. This is parallel line, yeah, parallel line of this. Since this is a midpoint, of course the other one must be also a midpoint, right? So we just prove that M E equal MF. Why? Because AT equal AF. Okay, and because they're congruent, right? So that's it. So that's kind of the second method. All right. So hope you follow the steps. You can pause the video and think about the steps. All right. The key step is actually try to prove that these two triangles are congruent here, right? So here, that's the key for method number 2. Let's move on to method number 3. All right. So it's all about how to construct, some special line and for you to prove what you want to prove. Here we're going to also do perpendicular line, but this time I'm going to from E and from F, right? From E, I'm going to try to do a perpendicular line here. Let's call this X. Let's call this Y. So I'm going to have EX perpendicular to, this line HM, and we have this FY perpendicular to this line HX. Of course, in that case, they're parallel, right? So I claim that the triangle are congruent. If a congruent, then I prove that the 9/7 is midpoint, right? So how do we do that? So we want to prove this right triangle are congruent, yeah? So which two triangles are congruent? So we want to prove this one here, yeah, and this one are congruent, yeah? So of course, because those are right angles here, yeah, you just need to prove maybe one side equal to each other and this angle equal to each other. So let's erase that. Okay, so how do we prove one sides equal to each other? In other words, if we can prove EX equal to FY, then we're done, right? So here I claim that I have a congruent triangle here, that is, I claim that triangle FAY, yeah, FAY is congruent to ACH. Okay, why? First of all, this right hand triangle, right, and then the sides equal to each other, right? Because if this is B, this is also a B, and the angle here, this angle, yeah, is equal to this angle. Similar argument earlier, right? This is 1 and 2 add up to 90, 3. This is 3. Yeah, this is like 1 plus 2 equal 90 degrees, and 2 plus 3 equal 90 degrees. So 1 must equal to 3, and then the two triangles are congruent. So this one was equal to B. All right, so we got it. Okay, so and now we need to prove EX equal to B. All right. Oh, sorry, it's not B. This is not B. This is there's a sorry about the mistake. This is AH, which is H, right? Let's call it H. This call it H. Okay, so FY, yeah, equal H. We're gonna prove that this is also H. So how do we do that? I claim that I have two congruent triangles here. I mark them as green. Okay, so one is this triangle here, somehow it doesn't work. Let's maybe mark it like that. This is better, right? So this triangle here is congruent with this triangle here. Yeah, why? Similar argument as earlier, right? So one is that if this length is C, this is also C, and this angle here equal that angle here, right? So we're done. Why? Because this is H. Indeed, this is H. So these two angles equal to each other, and then let's erase this. Yeah, so now I have this triangle are congruent to each other also, right? Because they have common length and they're right angles. Okay, so M is a midpoint, right? So that is done. This is method number 3. Now method number 4. All right, so you find it interesting that there's so many ways to prove this, right? So here, what we're doing here, we're going to construct a parallel line again. Let's call this x. So we're going to construct EX in parallel to AF. Yeah, and I'm going to extend MH, and then the intersection point is, you know, this is just a. All right, so we want to prove, if somehow we can prove this is equal to this, then we're done, right? Again, what is marking? So the size here could be, everything is B here, right? B here, and here, this is the parallel line here. So the angle 1 must equal to, this angle 1 must equal to angle 2, right? So how do we going to prove EX equal to B? I claim that I have congruence triangle here, right? So this time I'm going to look at this C. Okay, so I'm looking at ABC. Yeah, I'm going to look at this triangle here. Let's mark it as here, this one. Yeah. Okay, so this triangle here, I claim that I have one angle, right, equal to this as earlier. I'm not going to repeat that. Yeah, I have size equal, right? This size equal C, right? I have size equal C. And I have another angle here. Let me see. We need to prove so because this is a parallel line, right? So what I have is okay, it's very easy. So this big triangle here, right? This big triangle here, yeah. Let's call it 3, right? And this one is, no, that's 4. So 3 plus 4 equal 180 degree, because 9 are parallel, right? 3 and 4, this is 4. Now 4 and this, yeah, let's call it 5. So 4 and 5 is 180 degree. So in that case, 3 must equal to 5. Yeah, so I have one side and two angles equal to each other. So the triangle are congruent. In other words, ABC is congruent to, yeah. So EAX. So in that case, EX must equal to AC, and that means because AC equal to B, right? So here, what do you have? So EX equal to B and must equal to AF, right? AF. So since you do a parallel line, and this, if you claim that this is equal to each other, then of course this must be parallel, right? This XF. Let's erase this. Okay. So M is the midpoint because this is parallel. Somehow I couldn't connect the line here. Okay, so when we look at this shape here, So this is the midpoint. Because the intersection point is going to be the midpoint. So MEM equal MF, right? It's because we have this parallel line and the sides equal to each other. All right. So we presented 4 different methods here, right, of the original problem, and hope you can follow the steps. And if you have yet another method of proving the original problem, I'm interested in knowing your methods. Please leave a comments below. All right. So this is the original problem, and please subscribe to the channel for some other interesting problems. All right. Thank you.